Okay, so I just wanted to do a quick video on mass and weight, mass versus weight differentiation, and I wanted to clarify, although this video is very junior, and it's case 3 video, not even case 4, so sorry for the simplification. Mass is the amount of matter packed in any given volume in a body. It could be a sphere, point, disc, anything. Type of measurement of the amount of matter packed inside a body, whereas weight is the force exerted on that mass by the earth. So measurement of the amount of matter packed inside an object, and the object occupies space, so object has volume. It does not change, it's always constant unless it actually decreases itself. If you have this point M with weight being exerted, so this is a point mass, and if you take a bit of it, then it would be reduced. So unless you chop something out of it, only then it can get reduced, otherwise it would not get reduced. It's measured with a mass balance. Now weight is the amount of gravitational force on an object. It's the pull of the planet on the mass, which is always downward and perpendicular orthogonal in nature. So it's always acting perpendicular. Changes with reference to the location of the planet. It's governed by the universal law of gravitation, and it can be measured using a Newton spring or a spring scale. Let's convert these masses into a bigger unit. So we're converting all these grams into kgs. So the obvious pattern here is that you take the M in milligrams divided by 1,000, and that would give you your answer. So that's what I've done. 5 milligrams, 5 kilos. And that's it. Please take a look. So that's that. Now if it were 5 milligrams, then I'd have to divide it by 1,000,000. Just because it's a gram, I'll be dividing it by 1,000. But if it were a milligram, I'll be dividing it by 1,000,000 to convert it into kilos. These are all grams, so the factor of reduction is 1,000, 10 to the 3. Next one is, what units do we use to measure weights? That'll be newtons. Mass would be grams or kilograms. Just the symbol should do. Newtons per kilos. That'll be Newton meter squared. Newton meters per second squared. kg meters per second squared. mg, so that'll be so here it would be roundabouts, given the g is 10 newtons per kilo, so kg meters per second squared, newtons per kilo. So that'll be around about 200 kilos, 200 newtons. And that'll be 500. That'll be 1,000 newtons, or 1 kilonewtons. Now that'll be the original equation as W equals mg. To rearrange for mass, you'd get W over g. That'll be 80 kg almost, or just about. So that'll be 40,000 newtons. That'll be 4,000 kilograms. Okay, notice it's not grams, it's kilograms, because it's always in kilograms. The functional basic unit of mass is not grams, but it's kilograms. Okay, please remember that at all levels. What is g? So the g would be W over m equals g. Looking at around 0.94. 0.94 actually. Newtons per kg. Newtons per kg. So that's that. 75 divided by 80. That's round about 0.94 newtons per kg. Right? What's the mass if the force is 90 kilonewtons? F equals mg. And that will be sorry, I should have done that one math. So F over G, sorry. So that'll be 90 kilonewtons, 90,000 newtons divided by newtons per kg. So round about 334.5 kilos. I can't. Sorry, I can't do this question. Explain the difference between mass and rate to a year 8 pupil. I've never taught year 8s. I do H and C, H and D, year 11 and above. So I won't be answering this question. Not, it doesn't apply to me. Sorry. Where is the pull of gravity down on you when it's measured in newtons? Mass and amount of matter makes up an object or thing. Mass is measured in kilograms. I don't know why they say grams, because it's measured in kilograms. And whenever we do an equation and the answer comes out, we put kilograms in front of it because it's newtons per kg. So I don't think that's correct. This is wrong. This one's correct. It should be kilograms first and then grams. Yes, good. W equals mg. F equals mg. And as I wrote previously on the other page, it was F equals mg tan theta, which is a dividend product of mg sine theta divided by mg cos theta. Okay. Let's just if I'm 100 kilos, then okay, so I'm gonna just put 100 kilos, and so yeah, I just multiply it. 1,000 newtons. 380 newton. Newtons. 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 600. Okay, so that would be just a product of multiplied by 1,000. So that actually what you're doing here is W equals mg, and you take my mass and you're multiplying it by the g of the planet, and you get your answer in newtons. Okay, simple. Either increases or decreases. It either increases or decreases. According to my hunger, it'll be moon, and then Jupiter. Sorry. So the answer for this one is Jupiter, because gravitational pull is max. And then on which planet did you weigh the least? Moon. I mean, moon's not a planet. Moon's a moon. So so I wouldn't. If you really went into the semantics of it, the answer would not be moon. The answer would be a planet. So you'll have to pick a planet, not the moon. So in terms of planet, we have Mercury, which appears to be the one with the least gravitational pull. So it would be Mercury, according, if you were to go into the classical semantics of it. It's not moon, because moon's a moon. Moon's not a planet. Mercury's a planet. So the correct answer would be Mercury. On which planet was your weight most similar to your weight on Earth? All right, let's see. So here we have to do a bit of standardized notation. Okay, the standardized notation states you have to see we've got 10, our planetary pull is 10 newtons per kilo. So which one's closer, 11.9 or 8.9? So there's a difference. 8.9 is 1.1 less than 10. whereas 11.9 is 1.9 greater than 10. So I'd have to go for Venus. Venus. Yes, exactly, because Venus is less than what Saturn's more. So I have to go for Venus. So I can't do that garbage rubbish question. This one's garbage rubbish. Not gonna do this useless question. There we go. Thank you very much. I hope you enjoyed the video, and please do share it with all students. Thank you.